Okay, so this video continues Chapter 6 of Geometry. It covers 6.3 and 6.4. So by the end of this video, you're going to know some new properties about kites and trapezoids, as well as some new properties about midsegments. So, okay, starting with properties about kites. So a kite, as you might remember from earlier chapters, is this sort of shape where these two sides are congruent and these two sides are congruent. So the vertex angles of a kite are the angles between the congruent sides, so here and here. And then the non-vertex angles, as you might be able to guess, are these angles here and here. So now we have some conjectures about kites. So the first one, the Kite Diagonals Conjecture, states that the diagonals of a kite are perpendicular. So if we have this kite right here, then you can see the diagonals, which go from non-adjacent vertices are going to be these. And this looks more like, your normal kite that you might fly. But they are going to be perpendicular. So the Kite Diagonal Bisector Conjecture states that the diagonal connecting the vertex angles of a kite is the perpendicular bisector of the other diagonal. So if we look at the same picture up here, we can see that these two segments are going to be equal or congruent. So this diagonal is the perpendicular bisector of this diagonal. So now we have some more conjectures. So the Kite Angles Conjecture states that the non-vertex angles of a kite are congruent. So the non-vertex angles are these two angles, and if I had drawn this a little bit better, you would have been able to see that they are the same measure, whereas obviously these don't have to be. And then our next conjecture, the Kite Angle Bisector Conjecture, says that the vertex angles of a kite are bisected by a diagonal. So you can think of this sort of as, so we have this diagonal, and it is going to bisect these angles. You can think of it sort of as if you had two isosceles triangles, and then we know that the angle bisector here is going to be also the altitude and the median, which would translate to a diagonal in a quadrilateral. So a trapezoid can look a variety of ways. It can look something like this. It could look more like this. But the common theme is that these two sides are going to be parallel. So the two sides that I just talked about, the parallel sides, are called the bases. And then the base angles are going to be a pair of angles that shares a common side, or share a base as a common side. So this is a set of base angles, this is another set of base angles, this is a set of base angles, and this is a set of base angles. Okay, so now we have some conjectures about trapezoids. So the first one, the Trapezoid Consecutive Angles Conjecture, states that the consecutive angles between the bases of a trapezoid are supplementary. So this is pretty obvious if you think about it. We have two parallel lines. So these angles, as in any, if we say we continued these lines here, that's something you should have seen before. They are the consecutive interior angles, and they're going to be supplementary. So this next conjecture sort of defines what an isosceles trapezoid is. So it says that the base angles of an isosceles trapezoid are congruent. So an isosceles trapezoid is any trapezoid in which these two sides are congruent, and then think of it as sort of a shortened isosceles triangle. So in which we know that the base angles are congruent. It's the same thing here for trapezoids. And then we have the Isosceles Trapezoid Diagonals Conjecture, which states that the diagonals of an isosceles trapezoid are congruent. So say we again have these two sides congruent, then these two sides are also going to be congruent because they make the same path, essentially. They cover the same distance. So for a bit of practice, say we have this trapezoid right here, and we're given that these are congruent, and this angle is 128 degrees, and we're asked to find x and y. So we know that if this is an isosceles trapezoid, then the base angles are going to be congruent. So y is going to equal 128 degrees. And then we also know that in any trapezoid, the consecutive angles here are going to be supplementary. So then we can say 180 minus 128, that is going to be 52 degrees. Okay, so moving on a bit, midsegments is the next topic. A midsegment is a segment connecting the midpoints of two sides of a triangle. So essentially, if we have that this is the midpoint here and this is the midpoint here, then this is going to be the midsegment. So this conjecture states that the three midsegments of a triangle divide the triangle into four congruent triangles. So if we continue our drawing here and say that this is the midsegment here, we can draw that here, and we can see that these triangles do look pretty congruent. And this is going to be very useful information to have, because now we can go on and say that these sides are congruent, and these sides are congruent, etc., etc. So another conjecture is the triangle midsegment conjecture, which says that a midsegment of a triangle is parallel to the third side and half the length of the third side of the triangle. So say in this triangle we have a midsegment here. We can see that it's going to be parallel to the third side, if I had drawn it better, and we can also see that, so if we have this length, that's going to be just about half of here. And then the next conjecture deals with trapezoids. So the trapezoid midsegment conjecture says that the midsegment of a trapezoid is parallel to the bases and is equal in length to the average of the lengths of the bases. So we can see that it's parallel, and we can also see that it looks like to me that that's just about the same distance from here to here, so it's going to be about the average. So using what we just learned about trapezoids, if we have this figure here, and we're given that this side is 13, this is 24, this is Q, and we know that these are going to be parallel, and we know that these are going to be congruent. So then this is going to be the midsegment, and we're asked to find Q. So we know that this is the average of 13 and this base Q. So then that's going to be 13 plus Q divided by 2 equals 24. So then if we multiply both sides by 2, we get 13 plus Q equals 48. And then we can subtract 13 and we get Q equals 35. So then this side is going to be 35 units long.